We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard.
I feel the liftoff. The clock has started. Roger.
Godspeed, John Glenn.
Roger, 0G, and I feel fine.
This is a new and strange environment at first. This suddenly finding yourself in orbit.
We have a liftoff, 32 minutes past the hour. Liftoff on Apollo 11.
Houston, Tranquility Base here. The Eagle has landed.
Hello and welcome. This is Michael Annis, and you're listening to episode 14 of the Space Rocket History Podcast. And now, U.S. Space 1958, Explorer, Vanguard, Pioneer, and NASA. In mid-December of 1957, before any U.S. satellite had made it into orbit, the ABMA presented its vision for space exploration. It was largely based on projections from Wernher von Braun. This is what the ABMA predicted they could accomplish. In 1960, a 2,000-pound Earth satellite and an unmanned soft moon landing. In 1961, a 5,000-pound Earth satellite. In 1962, an unmanned circumnavigation of the moon with complete photographic coverage and a two-man Earth satellite. In 1963, a 20,000-pound Earth satellite and a manned expedition to circumnavigate the moon. In 1965, a 20-man Earth-orbiting space station. In 1967, a 3-man lunar landing. In 1971, a 50-man permanent lunar outpost. The cost of these programs was estimated at $1.5 billion per year. Of course, the ABMA did not receive a $1.5 billion budget per year. Instead, it would be absorbed into NASA. But I thought it would be interesting to understand von Braun's and the ABMA's vision of the future. Now let's move on to 1958, an important year for U.S. space exploration. First, a quick update on the Explorer series of spacecrafts. In 1958, there were 5 Explorer launches. Of course, you remember from last week's episode that on January 31st, 1958, Explorer 1 became the first U.S. satellite. On March 5th, 1958, Explorer 2 was launched by a Juno rocket, but it failed to reach orbit. The problem occurred when the 4th stage of the Juno rocket failed to ignite, and they actually had fuel in it this time. On March 26, 1958, the Explorer 3 satellite was successfully launched by a Juno vehicle. It was almost identical to Explorer 1. The mission objective was a continuation of experiments started with Explorer 1. Data collected from Explorer 3 combined with earlier measurements from Explorer 1 confirmed principal investigator James Van Allen's theory that radiation belts trapped by Earth's magnetic field exist around the planet. Explorer 3 decayed from orbit after 93 days of operation. Explorers 4 and 5 were tasked to gather information for Project Argus. Argus was a series of nuclear weapons tests and missile tests secretly conducted during August and September 1958 over the South Pacific. The goal was to investigate using a shield of radiation as an anti-missile defense. This is a 1959 news clip explaining the project.
Aboard the guided missile ship Norton Sound, the Viking rocket is ready for firing. The place, the South Atlantic. The time, last fall. This may have been one of the 3 rockets fired by the vessel about that time to explode nuclear bombs 300 miles high as part of Project Argus, the greatest scientific experiment ever conducted. The nuclear bursts in the vacuum of space threw a shell of radiation around the Earth within an hour. A globe-girdling network of thousands of scientists made observations. To monitor the radiation shell in outer space, the satellite Explorer 4th was launched, and all this in a secrecy not broken for 6 months. Most of the results are still not known. But it was a major breakthrough both for purely theoretical science and for military planners, hinting the possibility of throwing up a shield of radiation as a part of an anti-missile defense. In its vast scope and in its enormous accomplishments, Project Argus won proud new laurels for American science.
Explorer 4 was launched on July 26, 1958, and it was instrumented to make the first detailed measurement of charged particles, protons and electrons, that were trapped in radiation belts. Soon after launch, it was discovered that Explorer 4 had a tumbling motion that made the interpretation of the detector data very difficult. The low-power transmitter and the charged particle detector lasted until September 3rd. The high-powered transmitter and the remaining instrumentation continued to operate until October 5th. It's believed that the exhaustion of the batteries caused these failures. The spacecraft remained in orbit for another 454 days. On August 24th, the other Argus satellite, Explorer 5, was launched atop a Juno rocket. It failed when the rocket's booster collided with its second stage after separation, which caused the upper stage firing angle to be off. In the future, Explorer spacecrafts would go on to become the longest-running series of unmanned NASA spacecrafts, with a total of 78 missions. 73 missions were successful. Now, an update on the Vanguard program. You may recall from Episode 12, Vanguard Test Vehicle 3 exploded after achieving an altitude of 4 feet. On March 17th, Vanguard Test Vehicle 4, also known as Vanguard 1, had its chance to redeem the Navy project. Here is a recording of the launch made from the blockhouse.
8, 7, 6, 6, 5, 4, 3, 2, 1, mark.
The launch vehicle placed Vanguard into a 406 by 2,467 mile orbit. Original estimates had the orbit lasting for 2,000 years, but it was discovered that solar radiation pressure and atmospheric drag during high levels of solar activity produced significant drag in the perigee height of the satellite, which caused a significant decrease in its expected lifetime to only about 240 years. Vanguard 1 was pretty much a copy of Vanguard Test Vehicle 3. It used a similar 3-stage launch vehicle, and the satellite was pretty much the same. The goal of the mission was to test the launch capabilities of a 3-stage launch vehicle and the effects of the environment on a satellite and its systems in Earth orbit. It also was used to obtain geodetic measurements through orbit analysis. The grapefruit-sized satellite became the first to use solar power in orbit. The battery-powered transmitter stopped operating in June of '58 when the batteries ran down, but the solar-powered transmitter operated until May 1964, after which the satellite was optically tracked from Earth. The satellite is still orbiting the Earth today, making it the oldest man-made object still in orbit. Khrushchev's reaction to Vanguard was, quote, "They have put a grapefruit into orbit," end quote. Now let's move on to a new project called Pioneer. In late March 1958, President Eisenhower publicly announced the United States' intention to launch a spacecraft to the moon. He assured the nation that this was not science fiction. It was an achievable goal presented by a leading scientist. The announcement came less than 2 months after the first U.S. satellite had reached orbit. The President was committing the United States to a space race to the moon with the Soviets. If all went well, the country would have a spacecraft in orbit around the moon before the summer was over. The program entailed 5 ARPA, Advanced Research Project Agency, coordinated missions, 3 managed by the U.S. Air Force and 2 managed by the U.S. Army. The Air Force probes were to be lunar orbiters, and the Army probes would be flyby missions. The Air Force probe looked like a cylinder with a cone on each end. The cylinder was 29 inches or 74 centimeters in diameter, and the height from the top of one cone to the top of the opposite cone was 76 centimeters or 30 inches. Along the axis of the spacecraft and protruding from the end of the lower cone was an 11 kilogram, 24-pound solid propellant injection rocket based on the Falcon air-to-air missile. The Falcon rocket was used to slow the probe until it entered lunar orbit. The rocket and its case formed the main structural member of the spacecraft. 8 small, low-thrust, solid-propellant velocity adjustment rockets were mounted on the end of the upper cone in a ring assembly, which could be jettisoned after use. A magnetic dipole antenna also protruded from the top of the upper cone. The shell was composed of laminated plastic and was painted with a pattern of dark and light stripes to help regulate the temperature. If that description was a little hard to follow, you can see an actual picture of the probe on my website, spacerockethistory.com. The scientific package had a mass of 11.3 kilograms or 25 pounds. It consisted of an image-scanning infrared television system to study the moon's surface, a diaphragm microphone assembly to detect micrometeorites, a magnetometer and temperature variable resistors to record spacecraft internal conditions. Spacecraft was powered by a nickel-cadmium battery for ignition of the rockets, silver cell batteries for the television system, and mercury batteries for the remaining circuits. The launch vehicle was a Thor Able, which consisted of a Thor first stage and the second and third stages of a Vanguard launch vehicle. The launch vehicle was capable of sending 39 kilograms to the moon. The Thor Able stood 90 feet tall, with a diameter of 8 feet at the base. The first stage was liquid-fueled and capable of delivering 150,000 pounds of thrust. That was about 67,000 pounds more than the Juno 1, which launched Explorer 1. The second stage was also liquid fuel. It could deliver 7,500 pounds of thrust, and the third stage was solid fuel and could deliver about 2,760 pounds of thrust. Pioneer 0 was launched on August 17, 1958. 74 seconds after liftoff, the Thor booster exploded over the Atlantic Ocean. The cause of the explosion was suspected to be a failed turbopump bearing, which caused the liquid oxygen pump to stop. Before the launch of the second probe, the whole program was transferred to NASA, with the U.S. Air Force and the Army acting as consultants. NASA gave the probes the name Pioneer. On October 11, 1958, just 10 days after NASA's foundation, the second probe, Pioneer 1, was launched. Pioneer 1 was basically a duplicate of Pioneer 0. Here is the October 1958 news report on the mission.
At Cape Canaveral, another probe into space. Target, the moon. A 52-ton multi-stage rocket combining elements of the Thor ICBM and the Vanguard is readied for firing. Its payload, a toy, top-shaped instrument package with its own tiny rockets. This countdown has scant margin for delay. The missile must follow a carefully computed course if there is to be any possibility of intersecting the moon's orbital passage. And there is only one 15-minute go period for launching the rocket into that course. On the planned course, the 83-pound Pioneer space probe would closely approach the moon and be swung into orbit by the moon's own gravity. From its position 250,000 miles out in space, the moon probe would have broadcast back not only scientific data of enormous value, but the first pictures ever seen by human eyes of the far side of the moon. A daring and dramatic goal that was not destined to be realized on this day.
1, 0.
The
vehicle roars aloft at too steep an angle. Its velocity is cut by 800 feet a second, working more directly against gravity than planned. Reaching over 23,000 miles an hour, it carries to nearly 80,000 miles, 30 times as far as ever before. Another moonshot is scheduled next month. The Pioneer remains man's most resoundingly successful probe into space.
The reason Pioneer did not make it to the moon was the second stage shut down too early. Pioneer 1 needed to reach a speed of 24,100 miles per hour to reach the moon. It had fallen short by just 500 miles per hour. It did fly up to a height of 70,746 miles, almost a third of the distance to the moon. This was a new record, and the U.S. did receive accolades for that. It was hoped that firing the Falcon motor would put the probe into an Earth orbit, but the ignition failed due to low temperatures of the battery. Pioneer 1 burned up upon re-entry into the Earth's atmosphere 2 days later. The mission objective was not achieved, but the probe did transmit 43 hours of scientific data showing the radiation surrounding the Earth was in the form of bands, and it measured the extent of the bands. Pioneer 2 was launched on November 8, 1958. Unfortunately, the third stage failed to ignite. This caused the Pioneer 2 to burn up over Africa after a 45-minute parabolic flight. Following the less than successful Air Force NASA Pioneer 0, 1, and 2 lunar missions, the Army and NASA launched 2 more lunar missions. They were smaller than the previous Pioneers. Pioneer 3 and 4 each carried only a single experiment to detect cosmic radiation. Both vehicles were planned to fly by the moon and return data about the Earth and Moon's radiation environment. Both vehicles were basically identical. Pioneers 3 and 4 were cone-shaped, 23 inches high, or 58 centimeters, and 10 inches in diameter, or 25 centimeters. The cone was composed of a thin fiberglass shell coated with a gold wash to make it electrically conductive, and painted with white stripes to maintain the temperature between 10 and 50 degrees Celsius. At the tip of the cone was a small probe which, combined with the cone itself, acted as an antenna. At the base of the cone, a ring of mercury batteries provided power, and a photoelectric sensor protruded from the center of the ring. The sensor was designed with 2 photocells which would be triggered by the light of the moon when the probe was within about 30,000 kilometers of the moon. The launch vehicle for both probes was a Juno 2. This was an upgraded Juno 1. The rocket was 77 feet tall and had a maximum diameter of 8 3/4 feet. The first stage was liquid-fueled and could deliver 150,000 pounds of thrust, which is about 67,000 pounds more than the Juno 1. The second, third, and fourth stage used the modified Sargent solid-fuel rockets similar to Juno 1's spinning tub that was used to launch Explorer 1. Pioneer 3 was launched on December 6, 1958. The flight plan called for the probe to pass close to the moon's surface after 34 hours and then go into solar orbit. However, depletion of propellant caused the first stage engine to shut down 3.7 seconds early, preventing the spacecraft from reaching escape velocity. The injection angle was also about 71 degrees instead of the planned 68 degrees. The spacecraft did reach an altitude of 102,360 kilometers before falling back to Earth the next day. The final probe, Pioneer 4, was successfully launched on March 3, 1959. It did achieve its primary objective of reaching an Earth-Moon trajectory, as well as its secondary objective of returning radiation data about the moon. Unfortunately, the probe missed its targeted moon flyby distance of 30,000 kilometers. Instead, it passed the moon at 60,000 kilometers, about twice what was intended. After it passed the moon, the probe was tracked for 82 hours to a distance of 655,000 kilometers. And now, what could be the most important event for the U.S. in 1958, and that was the founding of NASA. If you recall from Episode 10, The Space Race, a full-scale crisis resulted on October 4th, 1957, when the Soviets launched Sputnik 1. This had a Pearl Harbor effect on American public opinion, creating an illusion of a technological gap and providing the impetus for increased spending for aerospace endeavors, technical and scientific education programs, and the chartering of a new federal agency to manage air and space research and development. On November 25, 1957, Senator Lyndon Johnson began hearings on American space and missile activities. This led to the February 6th establishment of a Senate Special Committee on Space and Aeronautics, with the goal of establishing a space agency and Senator Johnson as its chairman. On April 2nd, President Eisenhower sent the draft legislation to Congress establishing the National Aeronautics and Space Agency. At the behest of Eileen Galloway, who worked for the Congressional Research Service and served as a consultant to both Senator Johnson and Congressman McCormick during the drafting of the final Space Act, the name was changed to National Aeronautics and Space Administration. It was her belief that an administration with an administrator would be vested with more power than a mere agency with a director. And in fact, the new institution would need that power to coordinate with many other agencies. After congressional hearings during the spring of 1958, Congress passed the legislation, and President Eisenhower signed the National Aeronautics and Space Act into law on July 29, 1958. It was quite an about-face for a president whose staff members had belittled Sputnik 1 as a silly bauble and a neat scientific trick, and who himself had said that it had not bothered him one iota. On August 19th, T. Keith Glennon, the president of Case Institute of Technology and a former member of the Atomic Energy Commission, was sworn in at the White House as NASA's first administrator. NASA officially began operations on October 1, 1958, absorbing into itself the earlier National Advisory Committee for Aeronautics, Langley Aeronautical Laboratories, Ames Aeronautical Laboratories, Lewis Flight Propulsion Laboratory, the Space Science Group of the Naval Research Laboratory, the Jet Propulsion Laboratory, and the Army Ballistic Missile Agency, where Wernher von Braun's team of engineers were engaged in developing large rockets. NASA immediately contracted with U.S. military and military contractors to supply the rockets necessary to fulfill its objective of launching civilian satellites and spacecraft. This allowed the military to play an important support role in scientific programs, like the placement of astronauts in space, that no one branch of service could have done on its own. NASA gave the U.S. one central agency to coordinate space exploration, instead of the old system of competition between the Army, Air Force, and Navy that had created inter-service rivalries. Thanks for listening to this archive episode of the Space Rocket History Podcast. If you are financially able, please support the podcast by going to the homepage, spacerockethistory.com, and clicking on the orange Donate button or the Patreon link. Thanks.